Let us talk about this problem. We are given a circular linked list and a value k. We need to delete kth node from the beginning. For example, here we have a circular linked list with 3 nodes and k is 2. So we need to delete first second node and our circular linked list becomes 10, 30 and 30 connects back to 10. In this example, k is 1, so we need to delete the head itself. And this becomes our modified circular linked list. 20 is the new head. Let's now see this example. We have only one node in the circular linked list and we want to delete the first node, so our head will become null. In all these examples, we have assumed that number of nodes in circular linked list are greater than or equal to k. So this is our assumption in this question. Number of nodes greater than or equal to k. Let's first implement a solution with this assumption. We can always extend the solution by finding the length of the linked list and then comparing length with k. So let us first try a simple version. You may pause this video now and try to write down a function that takes head of a circular linked list as first argument, k as second argument, deletes the kth node of the circular linked list and returns the head of the circular linked list. Please note that head of the circular linked list will change only when you are deleting the first node. Otherwise, head will remain same. The solution of this problem can be divided into two cases. The first case is when you want to delete the head node, when k is 1. We have already discussed deletion of the head in detail in a previous video. Let us now talk about the second case, where the node to be deleted is not the head node. Let us take a look at this diagram to understand the solution. We have a circular linked list, k is not 1, so k is somewhere in the middle, and we want to delete the kth node. So to delete the kth node, we need to have pointer or reference to this node. Once we have pointer or reference to this node, we can change the next of this to this one. And once you do this, this kth node goes out of the picture. How do we get reference of this node or pointer to this node? We are going to have a reference or pointer that begins with head node. Then we are going to do current equal to current next. And how many times we need to do it? See, we want this current to come here, right? And current is currently here at the head node. So how many iterations or what should be our loop conditions to run the loop? So we'll run a loop for int I equal to 0 and I smaller than some value. You need to think of this expression so that we have current at the appropriate node. So current dot next in Java and current equal to current arrow next in C++. Now please pause this video and think of an expression here that you will write so that you have current here after this loop finishes. To understand the value of this expression, let's take some examples. When k is 2, you don't want to move current at all. You want current to be here, so your loop should not run at all. It should not run even for I equal to 0. When k is 3, you want to run this loop once, right? It should run once and it should come here because this is going to be the previous of kth node. When k is 4, you want to run this loop 2 times. First time current will come here, next time current will come here. So the expression that we are going to write here is k minus 2. So if k is 2, you will have 0. I is smaller than 0, so it will not run at all. When k is 3, you will have 3 minus 2, 1. So it will run once, right? You wanted this, right? If k is 3, we want once current to come here. So we have talked about the loop. We have talked about the idea. We also discussed that if k is 1, if head node is to be deleted, then we can simply use the previously discussed solution. Now please pause this video and try to write down complete code that takes head of a circular linked list as an argument, k as another argument, deletes the kth node and returns the new head of the linked list if head is changed, otherwise the same head. Here is complete implementation of the approach. We have if this condition, if head is null, we return head. We do not make any change into the linked list. If k is 1, if we wish to delete the first node, then we call delete head. So to see the details of delete head function, please refer the previous video where we have talked about deleting head of a circular linked list. If k is not 1, then we need to find out the node before the node to be deleted, right? So that we can change the next of it. Once we find this node, we change the next of that node to next, right? So we delete the current next from the middle of the linked list. In C++, we need to deallocate the memory also. So to deallocate the memory, we store current next in a temp variable. And then we do the same operation that we did in Java. And after that, we delete temp and we return head. So this is extra work required in C++ because C++ does not have automatic garbage collection. Let's understand the approach with this example. We have this circular linked list where head is 10. We begin current equal to head, right? And then we run it from 0 to k minus 2. So we are going to run a loop for I equal to 0, right? K minus 2 is going to be 3 minus 2, 1. So it will run for only I equal to 0, right? Because it should be smaller than 1. It should be smaller than 3 minus 2, right? Which is smaller than 1. So it will run only once and your current will come here, right? It will run only once. Current will become current.next. And once current comes here, what we do after that, we make current next equal to current next. So we break this link and we change this link to here. This is what we do in Java. In C++, we store the current next first. We first store the pointer to this node, right? Then we change current next to current next. And then we delete this pointer so that memory is deallocated. So this is all we need to do to delete kth node from a circular linked list.